Hello everybody. In this video we're going to be looking at something called the triangle inequality theorem. But before I start, I have a little demonstration for you. We're talking about the relationships in triangles, and in the first video we were really looking at how angles and sides affected each other. Well, in this video we're talking about all sides. And so what I've done is these are some spaghetti noodles I've broken, and I just want to show you that not every side combination can make a triangle. Here I've got three pieces that, if linked together just right, if the angles are adjusted just right, I can build a nice obtuse triangle, okay? However, if I change the lengths up a little bit, it looks like I'm building about the same thing, but with this set, it does not matter how much I change the angles, I am always going to have a gap somewhere. These are never going to meet up with each other. They're just going to close shut and never meet up. Well, what if I picked a different angle to work with, Over here. I'll attach these two. Now, it doesn't matter how skinny I make this one, it's always going to overlap. It's never going to build a triangle that uses the full side length. So whatever the lengths of this spaghetti is never going to form a triangle. So how do we determine that? Well, that's what we're studying in this video. Let's take a look at something called the triangle inequality theorem. The triangle inequality theorem says that in order for a triangle to exist, this must happen. And let's see what this says. This says the length from A to B added to the length from C to B has to be bigger than the third side. Or the other two sides, AC and BC, have to add to get together to be bigger than the third side. Or take the other sides, AB and AC, they have to add to be bigger than the third side. So what we're doing here is we're saying that any two sides of the triangle have to add up to be longer than the third side. Any two side lengths of the triangle must add to be more than the third side. That's what all that geometry language says right there. Well, instead of making this a three-step process, I've got a nice shortcut for you. Here's what we can do. You can take whichever is the smallest side plus the medium side, and as long as that is bigger than, more than, greater than the large side, then you have a triangle. I'm making a really big deal about this sign right here because there's no equal to here, guys. It's got to be greater, just like we saw in our demonstration with the spaghetti. So let's look at a couple of examples. The first set of examples says, circle each group of segments that could form a triangle. Now, I did not go out and measure all these lengths of spaghetti to show you. So we have to rely on this theorem. Okay? Well, in our first example, 5 is the small side, 8 is the medium side, and 11 is the longest side. So the question is 5 plus 8 greater than 11? 5 plus 8, is it greater than 11? And the answer is yes. 5 and 8 make 13, and 13 is bigger than 11. So this is one of my choices that would form a triangle. Okay, let's go down here. 7, 7, and 7. That's a little bit tricky. They're all the same. So that's like an equilateral triangle. I guess we could call that small, medium, large, but really they're all the same. So let's put it in the theorem. Is 7 plus 7 greater than 7? Well, 7 plus 7 is 14, and 14 is greater than 7, so that one works. All right. Number 3, 2 would be my small side, 4 would be my medium side, 6 would be the long side. So is 2 plus 4 greater than 6? That's the question. And the answer is a big no. It's not greater than 6. 2 plus 4 is 6. So that one's out. All right, down the next column. Side 1 would be small, side 14 is the medium length, side 20 is the longest. So is 1 plus 14 bigger than 20? 1 plus 14 is 15, and 15 is not bigger than 20. That one's out. Let's keep going. 6 is the small, 11 is the medium, 13 is the long piece. So is 6 plus 11 bigger than 13? 6 plus 11 is 17. 17 is bigger than 13. So these 3 lengths would form a triangle. And last but not least, it looks like we're dealing with an isosceles triangle this time. We have 2 sides that are equal. So we have a small and a medium and a long. Even though they're equal, they're the 2 smaller pieces. So is 3 plus 3 more than 8? 3 plus 3 is 6, and that is not more than 8. So these pieces could not form a triangle. You guys, all the pieces that could not form a triangle take us back to our example where when we tried to piece it together, the triangle never met up. There was always a gap somewhere. Okay, so or an overlap if you went the other direction. So all these ones that are X'd out are numeric examples of what happened here with our spaghetti noodles. Our second practice question is this. 4 boards were given to Sam to build a triangular picture frame for a large painting. Okay, which boards can Sam actually use? So Sam's going to try to build a triangular picture frame. All the boards are different, so he's going to have a small, medium, and long side. We're trying to find the combination that works in our theorem. All right, let's start with 8 as the small, 12 as the medium, 21 as the long. Is 8 plus 12 bigger than 21? Well, 8 plus 12 is 20, and 20 is not bigger than 21. So that one's out. Okay, there's no reason to try 32 over here. That makes no sense. If 8 plus 12 isn't bigger than 21, then there's no way it's bigger than 32. So I think board A is out. Let's try board B. If B was in, that becomes our small. The 21-foot board would become the medium. The 32-foot board would become the long. Is 12 plus 21 bigger than 32? 12 and 21 make 33, and 33 is bigger than 32. So board B, C, and D are the boards to use for this project. In this half of the lesson, we've been given all 3 side lengths, and we've been trying to decide if they were good lengths that would build a triangle. In the second part of our lesson, we're only going to be given 2 of the side lengths, and it's going to be our job to find the range of possible values for the third side. To do that, to find that range of possible values, it's super simple. To find the lowest end of the range, all you do is subtract the 2 numbers. To find the highest end of the range, all you do is add the 2 numbers. Let me show you what I'm talking about. Check out example 1. The lengths of 2 sides of a triangle are 19 inches and 32 inches. What is the range of possible values for the third side? All right, so here's a little visual. 19 inches and 32 inches, and we have no idea what this third side is. If this angle was super, super, super skinny, it would pull these 2 ends closer and the side would be short. If this angle is super, super, super wide, it would push the two ends apart and that side would be really long. So by finding x, we're finding what's the shortest it can be and what's the longest it can be. All right, well, the easy way is on the short end, subtract 32, take away 19, leaves us with 13. To find the upper end, we add 32 plus 19, leaves us with 51. So that third side can be anywhere from 13 inches to 51 inches, anywhere in between. It cannot equal 13 inches. It cannot equal 51 inches. It has to be between 13 and 51 inches. There is no equal sign in this theorem. All right, let's check a second example. This example comes with a picture. The diagram shows the location of Noah and Ben after swimming in different directions from a dock. What is the range of possible values from Noah to Ben? Okay, well, if Noah and Ben, let me grab some of these spaghetti noodles off to the side. If Noah and Ben swam at a really skinny angle close to each other like so, that's a short distance there. However, if they swim really wide apart from each other, if the angle between them is really wide, that's a really, really long distance. So this picture is absolutely not to scale. There's no way it could be. We're trying to find what's the range of possible values here. Well, the easy way to solve this is to subtract for the low end and add for the high end. 84 take away 63 leaves me with 21. 84 plus 63 leaves me with 147. So this distance between Noah and Ben is anywhere between 21 yards and 147 yards. It cannot equal 21 yards. It cannot equal 147 yards. It's somewhere in between. Final example here for you. Directions say circle all the possible values of x. And here's our possible picture. We have a side length that is 8. We have a side length that is 20. Our unknown value is not absolutely going to be one number. It's going to be a range of values. So let's come up with our in-between statement. For the low end, we subtract. For the high end, we add. 20 minus 8 is 12. 20 plus 8 is 28. So our possible values of x are somewhere between 12 and 28. 13 fits into that category. 9 is too small. 11 is too small. 12 is too small because it's equal to. 28 is too large. 22 is between 12 and 28, and 15 is between 12 and 28. If we go too small or too large, the triangle would not connect to form a complete polygon. If you have any questions, come see me or come see Coach Holter, and we'd be happy to help you out. Happy studying!